Good afternoon. My name is Gaiman Yi. I am the Technical Director of the i4energy Center. Welcome to the first seminar of the Spring 2011 Speaker Series. As you can see, I am not here in person. At this moment, I'm actually about 7,500 miles away. But with this pre-recorded video, I wanted to personally welcome you and to say a few words about the late Dr. Gary Baldwin. Gary passed away last November after a brief battle with cancer. Gary was a friend, a colleague, and managing director of the i4energy Center. This weekly seminar series is his brainchild, and it was very dear to him. It is my honor to announce the 2011 Spring Seminar Series is dedicated to the memory of Dr. Gary Baldwin. We have a terrific line of speakers, and I hope you can attend as many of the seminars as you can. Goodbye, and I'll be back in person on February 4th. Therese Pfeffer will announce today's speaker.
That's where he is now.
Yeah. Go ahead.
So, yeah, okay.
Paul's gonna, Paul Wright is gonna.
Good afternoon. Yeah, good afternoon, everybody. It's nice to see you. My name is Paul Wright. If you haven't seen me before, I'm the director of the Center of Information Technology Research at the University of Society. As you know, we have these Wednesday and Friday seminars. Friday virtually always on energy. We'd like you very much to come and enjoy the free burrito or whatever to be on the menu on those days. I just want to say a small story of myself about Gary, in that he was one of the people that helped to get Citrus from the ground up in the early 2000s. Without his sort of care and dedication for the whole of the Citrus organization, we wouldn't be where we are today. When a senior colleague passes away, we all feel this enormous loss. I feel this enormous loss in that the energy program was something that we really led. I just want to tell one short story that relates to something. You may know that there have been these, you do know that there have been these American Recovery Act grants. And the small story connected to Gary is that when we started in Citrus applying for those American Recovery Act grants, we were actually horrified at the amount of boilerplate that had to go with the grant. You had to fill in all of the financials, you had to fill in a very complicated schedule, you have to promise to work with industry, you have to jump through hundreds of hoops. And writing those grants is actually not possible in the end for an individual faculty member, because it's just too time consuming. You know, you're teaching, you're doing research, and you don't have the energy to do the work in these big grants. But Gary was a very good citizen in pulling those in, and a number of students, Jason Traeger, who's in the audience somewhere, are now funded by the grants that Gary wrote. So as a personal acknowledgement to Gary, not that the sort of high-level institutional activity which you, the students, probably are not that interested in, I do want to stress that his love and dedication penetrated all the way down to the student level and brought in many grants from the Department of Energy and so forth that are now making daily lives of daily students much better. And so I really do want to stress that big picture aspect of Gary, but I want to show the love and dedication he had to students. And that also reflected in his private life, where he had 4 children and several grandchildren. He was a really beautiful family man. So it's hard to applaud because you're holding a burrito, but I would just in your minds, just think about this wonderful person who's passed away now and realize that there are many people in the system who are working very hard for all of us, and especially working for students. So my love goes out to you.
Thank you, Paul. It is a great pleasure for me to introduce our speaker today, kicking off the i4energy series, Dr. Alan Meier, who is a senior analyst in the Energy Analyst Division, so in the Department of Turk, the National Labs for many years, and has done some pivotal work with standby power. His latest interest, I've actually have worked with Alan the last year or so on the Turk project that he's going to be presenting today. He has lived in Paris, worked for a couple of years there. He's been the founder and editor of Comprehension magazine, so start off our first talk today.
Thank you very much. The first problem is making sure I've got the microphone working. I think you're going to have to tell me whether it's on. Do we have sound?
I'm hearing that.
No? All right. All right. Help rescue me here, figure out what's going on, and thank you. So the topic today is measuring the usability of programmable thermostats and other really annoying devices. And the work I'm going to describe today has truly been a team effort, benefiting from the contributions and skills of everybody listed there. That includes Marco Pratoni, Therese Peffer, who just introduced me, Daniel Perry, and Cecilia Aragon. It also builds upon some of the earlier work by my colleagues Bruce Nordman and Rick Diamond, who started looking at thermostats, I hate to say it, almost 30 years ago, and I haven't forgotten what he learned from those discoveries. And then I should also add that this is research in progress, and you're going to see some of the rough edges as well as some of my ideas for future work. So with that in mind, let's think about thermostats a little bit. Residential thermostats are a pretty boring sort of thing, at least for now. I think that's changing. But they control about 10% of the nation's energy use. That is, the heating and the cooling in our homes. So I think it's important to make sure that we understand exactly, or at least as well as possible, how people interact with the thermostat and how the thermostat controls the energy use in buildings, since that is such a large fraction of our energy consumption. So where are we starting now? We have a situation that in about 1995, Energy Star created a specification for thermostats. And in that way, it endorsed certain high-quality, energy-saving, what it claimed, it used those words many times, energy-saving thermostats. And that program has been going on since about 1995. But then, in the around 2005, we had a situation where certain research started coming out suggesting that homes that with programmable thermostats used more energy than those with manually controlled thermostats. And so Energy Star was in a difficult position because it was advocating the use of energy-saving programmable thermostats, but the data were suggesting that maybe that wasn't the case. And it took the brave step of actually terminating its endorsement of programmable thermostats in 2008 until it could fix what it called the usability problem, because it realized that probably the reason these programmable thermostats weren't saving energy was as a result of poor usability. Now, with that in mind, I want to tell you a little bit about the rest of this talk. I'm going to present a few surveys of thermostats in homes, how we presented them, that tried to document and quantify the extent that these thermostats were correctly used, or at least all their features were being exploited. And then I'm going to describe, almost as a second talk, some of the methodologies that we've developed to quantify the usability of thermostats. And I'll tell you right now, what are the conclusions? Probably something you already know, that thermostats are really annoying devices, and they're a real pain to program and to get right, and that in fact, you as probably computer savvy and familiar with many kinds of technical devices, even you find them difficult to program and probably don't don't exploit all of their energy-saving features. Well, that's true for all of the country, and we'll show you how we discovered that. Secondly, I'm going to show you how we quantified the usability. We created a procedure, a methodology, if you wish, to quantify the usability of thermostats, which you'll see probably can be applied to other kinds of devices. So first question was, are the programmable thermostats that are in homes today being used correctly, and are their features being fully exploited? So what we did was we undertook a whole lot of little surveys trying to get at different kinds of groups of people to see how they used it. We didn't think we could get a representative sample across the United States. So instead we tried to use samples of convenience or whatever means to learn about how special groups and the average were using the thermostats. So none of these groups were statistically representative, but I think the combination of them begin to reflect the true situation. So we undertook parallel investigations, which I will describe in a moment, with using a weatherization crew, Amazon Mechanical Turk, and personal interviews and other surveys. The first one I want to talk about is a survey of weatherized homes. The government supports a major weatherization program which goes into low-income homes and adds insulation, perhaps replaces the furnace, and installs a programmable energy-saving thermostat. So what we did is we connected up with one weatherization crew and said, okay, what we would like you to do is before you do anything to that home, you visit it and administer a very short survey, so just a few questions so we know what the people think and how they're using the thermostat, and take a photograph of that thermostat in the home as you discover it. And here is an example of what we found, and I think it's worth reading this out loud. This is the response from one of these people that were visited. Do you use the programming features of the thermostat? Answer: yes. Are you satisfied with your thermostat? It's okay. Question: if you could have a new thermostat, what would you like it to do differently from your current thermostat? And we tried to give clues or suggestions like a different language, the font size, the button size, or some technical terms. No, nothing needs to be changed. Yet when we look at the photograph, what do we see? It's difficult to see perhaps in the slide, but the thermostat is on hold, which means all of the smarts of the thermostat are being bypassed, and this person is operating it like a manual thermostat. So much of what we learned here is that people don't really understand it, except that maybe they think that if the thermostat is installed, it automatically saves energy. That may be true for insulation, or maybe if you buy an energy-efficient refrigerator, but a thermostat is different. You have to take certain actions, you have to program it, and you have to reprogram it and reset it as you change your lifestyle. So among the homes that we visited, these are some of the things that we learned from the weatherized homes. And these are mainly low-income homes in Minnesota, I might add, in the middle of the winter. So about half of the homes had the thermostat on hold. And one of them, actually, 5%, had the thermostat switched off, which in Minnesota is just kind of worrisome. But here you could see that, at least in this group of people that made low income, the thermostats, half of them were just not using the features that were designed to save them energy. Now, that's useful for Minnesota low-income homes. We wanted to try to get a different sample of homes, which we thought we could do through the web. I'm not sure if you're familiar with the Amazon Mechanical Turk, but the Mechanical Turk is a service from Amazon where people, or sometimes called workers or Turkers, can complete simple computer-based tasks in exchange for a tiny payment. So, for example, you might look at an image and describe it in 10 words, and for that you'd get 8 cents. You might fill out a multiple-choice survey for 10 cents, or you might be asked to write a product review for a couple dollars or something. But most of these tasks are quick and simple. So we thought maybe we could use this Amazon Mechanical Turk as a way of collecting some data about how people actually use thermostats. And so on the left-hand side, you can see the procedure that the person requesting work fills out. We put some money in our account. We create our tasks, which in our case, our task was twofold. One was to fill out a very short form, just to learn a little bit about the user, and then have that person also photograph their thermostat and upload it. And this was really a very simple procedure. As you can see, the workers just fill out the survey, photograph their thermostats, and then they get paid via Amazon. And the next day, or whenever they're finished, we get the results nicely tabulated. If you can use this kind of procedure and you believe the results, it's wonderful. Well, what kind of results did we have? Within 24 hours, we had 63 people who filled out these forms, got paid a little bit, uploaded their pictures of their thermostats. And here that you can see on the right-hand side a map of where all those people were. So you can get some idea that we quickly got geographical diversity. What can you learn from this kind of information? Well, to be honest, you can't learn everything, but you can learn a few things that are important. You can learn, for example, that 20% of the thermostats had the wrong time set by more than an hour. If the programmable thermostat has the wrong time, it's unlikely that it's going to be working very well, and maybe not even saving any energy. Furthermore, once again, we saw this almost magic number or universal number that about half of the respondents had a thermostat that was on hold. Again, not using any of the features that we expected people would be using to save energy. And you might say, well, how do we know that these people were telling the truth? So we dropped in a few trick questions, like we asked the brand name of their thermostat, and if they responded with, we would give them multiple choice, like, what was it? It was Honeywell, White Rogers, and then we put Ford. And so if they ticked Ford, we knew that they were just sort of guessing on these answers. It was just kind of a control check that you have to do in these kinds of studies. But this demonstrated that you can learn certain kinds of information quickly, and we think relatively accurately. This study also told us that you can't put much faith in personal responses, that when you compare what people said and what their thermostat displayed, there was significant contradiction. So with that in mind, we are now planning a new study, a much larger one, which Marco Pretoni will probably report on in the future about thermostat behavior around the United States. Now, what I want to do is switch paths, and I'm going to talk about how do you measure the usability of a thermostat or some other device. And here's the problem. We have thermostats, and let's keep it with that for the moment. And how can we say that one manufacturer's thermostat is more usable than another? If Energy Star wants to create a specification that says we want to establish a minimum level of usability for a thermostat, they need to have a test procedure, some way to measure it, to make a score, a usability score that can then be applied, and all the manufacturers can use the same test, and Energy Star can go back and check to see whether the manufacturers were accurate. But this will give you the opportunity, or at least the certainty, that you are getting a more usable thermostat when it has a higher score than another. But how do you score or usability? How do you measure it? So this was our question about a year ago. So what do? You start taking videos. And let me just show you what happens. This is always a problem, excuse me. There we go. So this is a video of somebody who is asked to perform a certain task on a programmable thermostat. And I'll just start it, and then you can get some idea. So the task was to set the current time, a reasonable request. And if you can't set the time on a thermostat, you're not going to be able to use any of the programming and presumably the energy-saving features of this thermostat. So that's a reasonable task, but now the question is, how do you convert what's going on here? This clearly this subject who's having some problems figuring out how to set this thermostat. How do you convert this into something that's quantitative? And this was our challenge. And he's looking for something. He comes back. He's really trying hard, but he's pushed a lot of buttons. And now what is that? He's looking for maybe there's something to open, or maybe there's some buttons on the side. In fact, this one has a cover that's hinged, but there's no indication to the user that there is this hinged opening, and so he never found the fact that there were other buttons underneath there that probably would confuse him a little bit more. I'm sure you feel a little bit of both empathy, sympathy, and you've been in this frustrating sort of situation. So the question is then, how do you convert this kind of information, this clearly a usability problem here, into something that's quantitative? And that's what I'm going to talk about here. So let's see if I can restore the video just a moment. So how do you measure a product's usability? This is the way that we did it for thermostats, and we believe that it can be applied to other products. The first thing you do is you define a certain number of tasks, the representative tasks, the things you need to accomplish with that device, in this case a thermostat. Then you have to figure out a way to quantify the people's ability to accomplish those tasks. And as you saw from that video, there could be a number of things that you may wish to quantify, such as how much, the first thing you may start is, did the person successfully accomplish the task? And then you might ask, how long? Are there other kinds of metrics that you might be useful? You might want to measure the stress, the heartbeat, as this person gets more and more upset and frustrated. But all of these kinds of metrics are open to measurement and consideration. However, once you have figured out a way to quantify it, then you have to go to the next step, which is compute some sort of score based on these metrics of usability. I'm not going to talk about that very much here, but obviously that's something that Energy Star needs to do, because when it makes a minimum usability score for a thermostat, it needs to have that kind of methodology behind it. Eventually, you may wish to compare this thermostat to other metrics. To compare this thermostat to a reference case. Again, I'm not going to discuss this here, but these might be the steps you might use. So the first step is to define the tasks. In the case of a thermostat, we came up with 6 tasks that we thought were representative of what somebody needed to be able to accomplish in order to successfully use the features of this thermostat. They're not too exotic. Turn the thermostat from off to on. Set the correct time. Identify the temperature the device is set to reach. Identify what temperature the thermostat is set to reach at an arbitrary time in the future, such as 9 p.m. on Thursday. And put the thermostat in hold or vacation when you're leaving the home. And then also program a whole schedule for that thermostat. So those were the tasks that we considered. And then we had a laboratory. So the laboratory was not very complex. There you can see basically the thermostats are put on a 2x4, and we film the people as they try to accomplish those tasks. In our experiments, we had 5 different thermostat interfaces. We used 31 participants, and there were two interfaces per person, and each person did 6 tasks. And so there were 62 tests, and it turns out there are about 350 of those videos that you saw one of them, but some of them are very short. Some of them are very, very long, and we can talk about that a little bit later. Now, so these are the thermostats that we tested. There are actually 4 thermostats, and one was a web interface. We were kind of curious to see how we could do that too. You probably, if you have a thermostat, you may have one of these in your home right now. Or if you go to the store, you'd probably end up buying something similar to that. So the first question was, how did people perform in these tasks? And were we able to distinguish differences in performance among people? Well, sure enough, here is a chart that shows the seconds to complete a task. It's kind of a histogram compared to the percentage of users for task 1, which was turning the thermostat from off to basically on, to heat. And you can see that most of the people accomplished this task in less than 30 seconds. However, you can also see that there was quite a range scattered beyond that. Some people took more than 2 minutes to accomplish this task, which if you're cold, and it takes 2 minutes to figure out how to turn on your thermostat to heat, could be awfully frustrating. But the most important thing is that we were able, just using seconds to complete the task, to demonstrate that we could discern a wide range in performance of that activity. So that was good, so that we could see that whatever we were using these tasks was giving us data that had a wide variation in success. Now, the other question would be, can we actually see the difference in the interfaces and how that affects performance? And sure enough, here's the same task, and here now you can see average seconds to complete the task for these 5 thermostats, and you can see that there's an enormous difference in the average seconds to complete from the one on the left, which was 10 seconds, to the one on the right, which is over 80 seconds for the average time. And that doesn't include the people that were unable to complete the task. And so you can already see there's a drawback in this metric of using average time to complete, because how do you deal with those non-completes? Because if they are unable to complete a task at all, that seems like a severe design flaw in the thermostat. Then I wanted to show you the same results now for 3 tasks, and here you can see that there is some variation, that some thermostats are good in one task but poor in another. But you can see a general trend that if a thermostat is good in one task, it's probably going to be a little better in another, and so it's easy to kind of almost visually rank these in terms of usability. And so that's good. So what we're seeing is we're able to take these thermostats and be able to start at least getting a semi-quantitative sense of what is a good thermostat in terms of usability and achieving certain kinds of tasks. I wanted to show you this because Consumer Reports, by no coincidence, had tested a couple of these thermostats also. And the one that we found to be the poorest in usability, Consumer Reports rated as the best. Not in usability, but the one that they recommended. And that's part of the reason that they were looking at many features. But I also wanted to illustrate some of the other features. how did Consumer Reports test their thermostats? This is a picture of one of their subjects. Actually, it's not a subject. It's one of their expert panelists testing out the thermostats. Now, I don't know how many of you have actually had the pleasure or the luxury of using a thermostat while sitting down in a well-lit room. Most thermostats are located in a poorly lit and inconvenient location, and so one wonders how realistic is the situation. For Consumer Reports, this may be the right way to judge, but in terms of usability, this is not obviously a very realistic measure. Now, we considered several other metrics. I mentioned in the ones that you saw before, the fact that we did average seconds to complete, but there are other kinds of metrics you might consider. This is one we played around with, which we thought was cute. We called this lostness. And what we did is we examined the videos very carefully and were able to determine which buttons the subject pressed. And so on the right side of that table, the actual keystrokes by the subject, those are codes for each of the keystrokes. And then you can see one halfway down, CD times 10. That means that subject pushed that button 10 times in a row. But this is information that can be gleaned from the video. We could also go into the manual and figure out what the minimum number of keystrokes to accomplish that task was, which in this case was 3. And so you could figure out something that we called the lostness coefficient, which was 28 strokes, the actual keystrokes divided by the minimum, and something like 9, which it's cute, but it's arduous data to collect. And sometimes that the subject will be punching the button 200 times. And there's also ambiguity in deciding if a keystroke actually occurred. And so it was worth looking at, but in the end we couldn't use that. So we began thinking a little bit more about what is the optimal metric for usability, because the average seconds to complete, while interesting, wasn't enough. And so we needed to think about what were the criteria for a good metric. And those included relying on actions that are easy to observe, measure, and are unambiguous. We also wanted to capture the essence of usability. And in the longer term, we also need to think about having a closed-end scale, that is a value between 0 and 1, that would allow us to combine the results from different tasks into a single number or score for usability. Because obviously, if you use something like average seconds, some of these might have average seconds of maybe 4 seconds, and another may be 120 seconds, and that suggests that the task where it's 120 seconds is more important than the task that's 4 seconds, and it may not be the case. So you needed to figure out a way to combine the data. I'm not going to go into details here, but we found that a logistic function looking like this met our criteria. It combines the time to complete a task with the assignment of 0, that's to the value c, if the subject failed to complete the task. And then there's a coefficient k that weights the importance of non-completes compared to the time to complete. But this introduces a new problem, because you have to decide what should the value of k be, and we're still trying to figure out what is the correct value, but it's got to be empirically derived. But we use this kind of coefficient and this metric to create something which we call the combined completion coefficient. And now this is based on 3 tasks that we described before, and I removed the thermostat names there. I apologize, but it's not so important. But that is the real the same data, and we've now combined the 3 tasks. So in a sense, this is a score of usability. It captures the usability if you accept the fact that those 3 tasks represented the usability of the device, and you can begin to see that we are getting numbers where we are confidently discerning the differences between these different interfaces. So I think as we move forward, we're not finished with this project, but I'm fairly confident that the next thermostat you buy will be easier to use, at least if it's an Energy Star thermostat, because Energy Star has adopted this methodology. It's not finished yet, but I think you will see that manufacturers will begin using something like this as a way of making sure that their units are more usable than others. They may start bragging about it. They certainly will have to comply with Energy Star. And so that I'm reasonably certain that in the next 5 years, this is the way we are going to be measuring the usability, at least in this product. So what's next? Well, how about lighting controls? This is a picture I took from a building from my colleague Gary Kloss sent me of a lighting control. The first question is, what is this device? If I hadn't told you it was a lighting control, would you have even known that? Anyway, then you can see that the users of this device have been so frustrated, they labeled it. The green means probably on. Well, we know it means on, and I'll explain in a moment. And then the red is off. But and then you can see that somebody else further retrofitted it. It's very faint on this picture, but they scribbled on a pencil on and off on the green and then the red respectively. And what the buttons in between mean, who can say? Now, a lighting control is a very different kind of situation. It's kind of a different kind of use situation than a thermostat. But you can see that it lends itself right away to the same approach. You can define some of the tasks, determine the status of the lights. Do you know, if you look at this right now, what is the status of the lights? Sometimes you're not in the same room as the lights or something like that. You have no idea what's going on there. How do you turn it on, the light? Well, thankfully, some human got in there and gave you some information. It's the one that is most useful, of course, is the ones that are scribbled and you can barely see. It says on and off. But what about all that stuff in between? And what this probably is a dimming light. How do you dim it to some level? And these would be the kinds of tasks that you might test on this lighting control. Now, my colleague Bruce Nordman would also remind me that maybe the highest priority is to standardize some of the symbols and icons on these kinds of controls, so that if a stranger comes up to this device, first of all, they'll know it's a light switch, and second of all, they'll know some of the key controls in order to make it work, because those symbols are familiar to him or her. But still, as I said, it's also easy to start defining the tasks associated with lighting control and follow the path that we developed for thermostats. Okay, maybe you're not convinced about lighting controls. Here's the next product that's coming to your homes. Maybe not in California, but about 30% of the nation's water heaters are electric resistance. They use a lot of electricity. It's one of the highest using, one of the end uses with the highest consumption in homes. And they are now being replaced with something called a heat pump water heater. And these are a wonderful invention, because you drop in this device and you will reduce the electricity consumption by 50%. It's rare when you can find such a large energy savings. However, these are the controls that you will see on the heat pump water heaters today. And I challenge you to make sense out of them. And the reason that's important is because one mispunch of the buttons can change your energy consumption from 1,500 kilowatt hours to 3,000 kilowatt hours a year, and you won't know it by these controls. it's very easy to make a mistake. So these are areas where, again, you can start imagining where there may be some kinds of usability criteria that will be added. One of the things that's important in the thermostats is we're not guaranteeing that you're going to save energy by putting in a more usable thermostat. Our premise, however, is that if we have a more usable device in there, we will facilitate energy savings. Somebody else has to educate the users and say, these are the right temperatures and the right schedules for you to use to save energy. But at least the thermostat won't be an obstacle to achieving those preferences, those thermal preferences that you've been taught to do. As you can see from some of our studies, that most of the programmable thermostats today are basically disabled and made into a dumb thermostat, and through basically being put on hold, or maybe they don't even have the correct time. I showed you that we do have a methodology that effectively, I believe, captures usability. I believe it can be applied to many other products with some adaptation, but it is ready to use. But what I really want to do is conclude by commenting on the future of the thermostat, because this is one of the most exciting things that's going on. In the last decade, that thermostat, which has been an appendage to your heating and cooling system, there's been a wire connected. It's now being, that connection is being broken, and the thermostat is now becoming an independent product in the consumer electronics field. And so, whereas the thermostats used to come from Minnesota and upstate New York as part of a mechanical device, it's now shifted over into Silicon Valley. And it's an exciting area because it's in total flux about where, for example, the functionality of a thermostat is going to reside. We don't know whether the thermostat is going to reside in your PC, in the cloud, in your mobile phone, in your Xbox, or in your utility meter, or little bits of all of those. And that's, I think, what makes this so exciting right now, because the technology is changing so fast, and the opportunities are also growing. But it doesn't really matter. With respect to usability, there's still the same fundamental problems that people need to fulfill certain kinds of tasks to achieve thermal comfort while saving energy. And so I believe that, again, the methodology and the approach that I've described today is still relevant. And with that, I thank you very much, and I will be happy to take some questions. Any questions? There's one in the back row.
It seems to me you're conflating learning curve and usability. Like if there's a hidden panel on a thermostat, once they know there's a hidden panel, how easy is it for them to use? And for example, what if you showed someone how to use the thermostat, then you measured how quickly can they do functions on the thermostat? There's a question of motivation involved. So there may be, for some people it may be an easy thing. A given thermostat may be very easy to use, and it may not be for other people. So it seems there's a lot more complexity to the measurement and to defining usability than what you've shown us so far today.
You have a very important point that you need to take into account the learning rates or the learnability aspects. And in fact, we could do tasks like that, and we've tried to decide whether we should have a task that first allows the person to learn that there's a cover or something like that. And you know, the fact is some of these people don't touch thermostats for 6 months, and they can't remember how it works. And so in the end, we decided in this case not to include learnability. But we could easily create these tasks in such a way so that it would include the learning feature. And I'd be happy to try that in the future.
Alan, first of all, great talk. I think this is really important research, and obviously the results are troubling. And as I was listening, I thought, boy, you know, I bet it's actually worse than these data suggest. And one thought that came to my mind is that in the usability test, you are giving the subjects tasks. You're defining the task for them, right? So you're testing whether they can execute the task, but what you still don't know is whether that subject could have formulated that task independently, right? To actually define what it is they have to ask the thermostat to do such that they will be comfortable in their house while minimizing energy use. And I'm sort of curious from the pictures that the photos that you have of the thermostats, of the ones that were not on hold, and of the ones, and what other kinds of, you know, issues do they have? I think it would be very difficult to actually compare if they were programmed in some way. Did that program have anything to do with actually accomplishing, you know, making the house comfortable and using less energy? That would be very difficult to test, I think. So
working backwards, yes, it would be very difficult to test. And it's hard to collect all that information, too. So from a research perspective, unfortunately, I don't know how to deal with that. But your first question was about maybe the consumer doesn't even know how to formulate the question. And we tried to some extent to formulate the tasks in as almost deliberately ambiguous way so that we don't give them the clues of the right word to use. At the same time, you know, there may be an obligation for Energy Star and others to start recommending or requiring that certain words and terms and icons appear on all thermostats so that everybody knows, oh, I want an away button because I'm leaving and I know what that does. And it doesn't matter which thermostat, I can just punch that away. And we sort of have that with security systems. There's a question over there.
I wanted to for you to comment on the fairness between embedded devices that are sitting on a wall versus sitting in front of a computer web screen. It seemed that perhaps you did not include the walking into the office and booting up the computer and logging onto a website in those 10-second numbers to do certain tasks. Could you comment on that?
Yes, you are correct.
Yeah, I really enjoyed the talk. I had a question about how the manufacturers have responded, if at all. And a sort of a follow-on question is sort of much like EPA fuel economy tests. Is it possible that once you set up this, necessarily narrow metric, sort of just a limited set of sequences, is it possible then that manufacturers design the thermostat to meet that, but maybe there are other aspects of usability that you don't capture that are potentially more important? I suspect you would say no because you've designed the test, but have you thought about those things?
So you have two questions. First, how have the manufacturers responded? And the answer to that is a little bit complex, but basically there are two kinds of manufacturers. There's the traditional type where they're used to the idea of a wire connecting the thermostat to the heating system or the cooling system. And then there's this new group that is thinking about the thermostat as a new kind of consumer electronics product. Need I say more that their views are very different? Then you talked about the possibility that manufacturers may circumvent test procedure, this methodology, or somehow tune the thermostat so it works very well on the test procedure, but actually ends up to be unusable. That's always a problem, and I'm not quite sure how to deal with that, but it's something we have to watch for. Personally, I'm more concerned that the test procedure may stifle innovation. And so how do we make sure that, for example, one of the areas that I'm curious about right now is the Xbox Connect. What if we made the thermostat became your, what if the Xbox Connect became your thermostat and used all sorts of new kinds of information and audio and visual and maybe even checking to see if you're physically comfortable by what you're wearing? How is that going to fit in here? And this comes back to the final sort of question I had is, I don't know where the functionality of the thermostat will eventually reside. And so we have to figure out a way to make sure that we allow that kind of innovation to continue.
Great question. I mean, the research seems, you make it sound very straightforward, but it's a brilliant question, this usability question. So it seems that the one that ranked the best was the web interface one, correct?
Well,
there was one that had web, and then there was a picture that looked like a web browser.
Yes, in some cases.
The browser was actually built into the device, or was that over the network?
No, it was separate. It actually had there were two versions of it. One was the web-based interface, and then it was also a thermostat. And the thermostat part of it, the wall unit, did fairly poorly.
I see. So could we possibly conclude that using existing user interface metaphors leverages, I mean, everybody makes their user interface in software now look like the web if they can, even if it's not actually a web browser. So I was thinking what software engineers try to do is reuse existing sort of metaphors once they get one that works. And it just seems like a dimension that might be testable. Like, remember when Unix had all these different, the UIs were very incoherent, and now we've got GNOME, and they use existing, just everything's with the same sort of widgets, and so it's easier to mentally process. So I'm wondering if that would be a dimension worth trying to test, or maybe even if you can't test it, try to suggest to manufacturers, hey, could you make everything look like something familiar? Like, for example, make even if we don't know how the thermostat should look, could they look like each other? And could they look like the web? Just because people know how to process that. Many times I have trouble with the UI just because I can't, I feel like you said, this is a lighting switch, really?
I'm not sure how to fully answer your question, but I think that first of all, we have to recognize that there's a huge diversity in people. Not everybody is going to be on the computer. We can't rely on the web. Can we draw upon some of these metaphors and concepts across platforms? I hope so. But there's a lot of research there, and I'm going to try to avoid the rest of possible answers to your question by saying, yeah, we need to investigate that.
One question. I doubt you got the data from the manufacturers, but were you able to get verbally from them what the warranty or the return rate was, and then what percentage of it were okay? You know what I mean? In other words, if they returned and you like 80% of them were fine. Did you get any of that data off the record?
I'm not sure what you're leading to, but I'm going to answer a slightly different question that is still relevant, and that is, one of the manufacturers bragged to me about their hotline, that they had lots of people, and he bragged about how many people he had answering questions from users who had questions about how to operate their thermostat. So I think what they were trying to do was avoid having people return the thermostat because they couldn't get it to work, but mainly those consumers thought it was broken, but it was actually just so unusable that they never successfully installed it.
The other thing was, since it's on the wall, has anybody thought about doing like an apps on an iPhone so that they can see, on your mobile phone to help, program?
Absolutely. It's this is clearly one of the places the functionality will reside is on your mobile telephone, and it already exists in a couple of cases.
Thanks again.
Okay. Thank you. well.